Welcome to section 4.7. We're dealing with completing the square, and what this allows us to do is to solve our equations for quadratics in a slightly different manner, but that ends up being a lot easier than what we're going to show you tomorrow, although you're more familiar with tomorrow's stuff. So let's take a look. First thing we're going to do though is we're actually going to solve our first equation, x minus 5 squared. And we ask you how many answers. We talked in section 1 that because the degree equals 2, that means that I have 2 solutions. And don't forget that the degree is the exponent, the highest exponent that we're working with, and so you can see the x squared there. Now, what we're going to do is we're going to look to try and get the value of x. The problem is x is inside the parentheses, and so in order to solve that, we've got to get rid of what's outside of the parentheses first. And you'll notice the squared is outside, so what we're going to do is we're going to square root both sides, which is the opposite or the inverse of squaring. Now, when I square the left-hand side, the square root and the squared go away. So I have x minus 5. Sorry about this. And when I square root 49, when you square root, you get 2 answers. The positive and the negative version of 7, because when you square 7 or negative 7, you can get 49. So as I look at this, now here's the problem. I have 2 equations now to solve. Okay, I have when x minus 5 equals the positive 7, and I have when x minus 5 equals the negative 7. So if I solve both of these, basically we look at it, we know we add 5. My first one gives me that x is 12. If I add 5 in the second equation, I get that x equals negative 2. Because they're separate, I have an OR, so I have 2 possibilities for my answer. I can plug in a 12 and get 49, or I can plug in a negative 2 and still get 49. And that's what we're saying here, okay? And this is giving you the basic idea of how to solve, and then we're going to expand from there. Now our goal as we go along is to get something, some binomial squared. Like we have up here, this x minus 5 quantity squared. And I'm going to show you when you actually can factor, so we're going to go back to 4.3 for a second. If I look at this left-hand side of my next equation, x squared plus 20x plus 100, the question is this factorable? Can I look at 100 and find 2 numbers that multiply to 100 that add to 20? And I'm hoping it's clicking in your mind already. If I look, 10 times 10 is 100, and 10 plus 10 equals 20. So if we go back to our factoring, we know that x plus 10 times x plus 10 will factor there and end up, I can set it equal to 81. But we don't want to write it like this. We want to write it as the square of a binomial. Since they are the same, I can say x plus 10 quantity squared equals 81. Now I want you to circle your equation in factored form every single time, because this is going to help us later start talking about vertex form, which we did in 4.2. And so what I want to do is as you're going through, I want you to circle your factored equation. And then we're going to take a second part and we're going to solve it. And what you'll find today as I go through this is I'm going to take everything in 2 steps. Now I have my equation. Let's write that again. X plus 10 quantity squared equals 81. Well, to solve this, I got to get rid of the squared first. So I square root both sides, and I get that x plus 10 equals, when I square root, I always get a plus and a minus, and the square root of 81 is 9. So I write my 2 equations, and I say x plus 10 equals, let me actually make that a 10. X plus 10 equals positive 9, and an x plus 10 equals negative 9. Now I'm going to solve them the same way. Subtract 10, I get x equals negative 1. Or, if I subtract 10 over here, I get x equals negative 19. You still should come up with 2 solutions because I had an x squared to begin with. But what I want to see in your work along the way is this factored form and then your 2 solutions. okay? Now this is really nice and will happen very rarely when you can actually factor the left side. We're looking at concerns if we can't factor, and we gave you some in section 4.3 or 4.4 that weren't factorable. And so we're going to look at a process called completing the square that allows you to get this factored form in kind of a reverse factoring, and I'll show you that as we go through. All right, now you'll notice I have a lot of stuff here going on, and I'm going to walk you step by step through exactly what we need to do in order to find this binomial squared equals a number, to find a factored equation. So here's what we're going to do. We're going to start with our x squared minus 10x plus 1 equals 0. And our goal is to get rid of the constant, and the constant is the number that doesn't have an x. So I'm going to move this constant to the other side by subtracting 1. So I have an x squared minus 10x equals negative 1. And your first step, if I look at this, I can't multiply any two numbers to get a negative 10. So I'm going to move the 1 over so it's not part of my factoring. Now, what I'm going to do is show you a process for completing the square, and I'm going to write it maybe a little bit more in depth than other people will, but I want to show you this general idea. Here's what I'm going to do. I know that x squared minus 10x plus something could equal negative 1, and if I add something on the left side, I have to add the same thing on the right side. Now I'm always going to write this step because I'm going to complete the blank, okay? Now if you remember the one above, we said the number on the end multiplies to get this number here, and it will add to get negative 10, okay? So I'm going to start with the addition a second. The question is, what number plus itself will equal negative 10? And if you look, you should get negative 5 plus negative 5. So negative 5 plus negative 5 equals negative 10. If I multiply those two together, negative 5 times negative 5, I end up getting a positive 25, which will complete my square. If I add 25 on the left side, I have to add 25 on the right side. Now let me show you how this works. If I pretend this stuff wasn't here, could I factor this? Well, 25 is negative 5 times negative 5, which then factors to x minus 5 and x minus 5. And this is our goal, is to be able to write two factors which have the same constant in that binomial. So they both have the negative 5. Equals negative 1 plus 25 is 24. Okay? Now, I don't like how this is written on the left because we know that these binomials are the same. So I'm going to write it as x minus 5 quantities squared equals 24. And I said to you, once you have your equation, please box that in, because I'm going to help you make some sort of connection between what we've done before in that equation coming up. Now, once I have that, our goal now is to solve it, okay? So as I go through and solve, and I'm going to need maybe a little bit extra, but we'll try this. X minus 5 quantity squared equals 24. And to get rid of the squared, we square root. So I have x minus 5 equals plus or minus. Now the problem is 24 can be broken down with a perfect square root. 24 is 4 times 6. And if I square root both of those, 4 is 2. The square root of 6 I can't do anything with, so I leave it as 2 without a square root, and then the square root of 6. Now I'm still solving for x, so I don't want this minus 5, so I'm just going to add 5 to both sides. I'm going to write my answer over here. I'm going to put the 5 in front so I can still say plus or minus. So I say 5 plus or minus 2 square roots of 6. And this is my answer. And really, it's 2 answers because I have 5 plus 2 square roots of 6 and 5 minus 2 square roots of 6. Now this, if you're looking at me going, I don't even know what number that is, you could change those to decimals and plug them back in to verify that they work in your equation. For right now, though, your answer has to be exact. There are no decimals for me. And if it's exact, then it means it has to contain the square root or be a whole number. Okay? So this is the process. Now I'm going to walk through some more of these with you, and we will do some more in class, but I'm trying to get you to break down the process step by step. Okay? So let's scroll this down, and let's just try and figure out what in the world, what the numbers are that we're supposed to add each time. Okay? Now, this says find the value of C so that we can actually complete a square. So, the question is, how do you get 28 by adding the same number to itself? So 28 is 14 plus 14. And that's important because the value of C is what you get when you multiply 14 by 14, which is really 196. So if I'm doing 14 and 14, then I know that x plus 14 and x plus 14 are what I would get if I factored. But I don't write it like that. I'm going to write it as x plus 14 quantity squared when C equals 196. And it's got to be 196 because if you go back and look, x squared plus 28x plus 196, you would have done this. Well, what two numbers? 14 and 14, so then you get this again. And that's our goal is going through, is what would it have to look like to be able to factor? Okay? Now let me go a little harder for a minute. I have x squared minus 9x. 9 is not a number where you can think of two whole quantities that add together or add plus itself to get 9. But so what I'm going to do is split 9 in half, because we split 28 in half and got 14 and 14. If I split 9 in half, what I end up getting is negative 4.5 and a negative 4.5. So I'm going to add those two numbers together in order to add to negative 9. The question then is C is when you multiply negative 4.5 times negative 4.5, and that ends up being 20.25. Okay, now these are all really nice decimals, so I'm going to let you keep them. Normally, again, if they're decimals that repeat, we're not going to do it, but in this case, I'm okay. What that says to us in our factors is it's x minus 4.5 and x minus 4.5, which we write as x minus 4.5 squared. This only can work, though, when we plug in a value of C of 20.25. Okay, and so this is kind of the idea of what we're doing. Most of the time I'm not giving you decimals. If I'm going to give you a decimal, it will be a nice 0.5 that you have to work with. Okay, so let's try another completing the square now that we've looked at kind of how to pick our numbers. So scroll to the back side. Okay, and we're looking at the back side. Now, here's a difference as you already look at it. If you look, instead of just a single x squared, I now have 3x squared. Not a big deal because 3 and 36 and 150 are all divisible by 3. So what we're going to do is divide each of these quantities by 3, and I should do it on the other side, even though it's not going to change anything here, but it might at some point in time. If I do that, I get x squared minus 12x plus 50 equals 0. Okay? Now, we got to look at 50 before we do anything. Can you find two numbers that multiply to 50 but add to negative 12? Well, 50 is 5 and 10, not doable. All right? 2 and 25, not doable. 4 and, nope, not 4 and 15. You're looking at a couple and you're thinking, nope, Ms. Japan, it's not going to work. Okay, if that's the case, we're going to move then the 50 to the other side. So x squared minus 12x, I'm going to leave my blank, equals negative 50 plus whatever. Because whatever I add to one side, I better add to the other side as well, so I'm not affecting the equation. Now let's go back and let's complete the square. How do you get negative 12? Well, negative 6 plus negative 6. And if I'm adding a negative 6 and a negative 6, then I multiply negative 6 times negative 6 to get a positive 36. And if I do a positive 36 on this side, I better do a positive 36 on the other side. Because I use negative 6 and negative 6, I should have two factors of x minus 6 and x minus 6, which equals negative 50 plus 36 is negative 14. But I'm not going to write it like that. I want it in factored form. X minus 6 squared equals negative 14. I box in the equation that I'm going to use, and then I'm going to solve it. Now I'm going to put my solving over here so I have enough room. So I start with my x minus 6 quantity squared equals a negative, let me rewrite this, a negative 14. Okay? Now we get rid of the squared first, so we square root. X minus 6 equals plus or minus the square root of negative 14. Now, according to 4, 5, and 6 that we learned, when you have a negative underneath the square root, that means you have an imaginary number called I. So this translates to an I. 14 you cannot break down because 7 and 2 are not perfect squares. So I have x minus 6 equals plus or minus. I comes out front because of the negative, and what's left is the square root of 14. Now, I'm still solving for x, so I add 6 to both sides, and I get that x is 6 plus or minus I square roots of 14. And I'm done. So I should have two things boxed in every problem you're doing. One is the equation in factored form, and then two is the two solutions. You may leave your solutions in plus and minus as long as it's not just whole numbers, as long as you have square roots involved. Okay, and I'll show you what I mean because there's another one coming up that's different. All right, let's do an application of it. The area of a triangle is 144. What's the value of x? Now, your paper has a triangle, so let me draw it in. The bottom length is an x plus 10. The height is a 2x. Now, let's talk again about area of a triangle. In order to find the area of a triangle, it's 1/2 times base times the height. So if I look at this, I have 1/2 times the base, which is x plus 10, times the height of 2x equals 144 according to my problem. Now I'm going to simplify this a little bit. Multiplication, it doesn't matter what order you do them. So I'm going to take the 1/2 times the 2, and I'm going to cancel that because that's just 1. And then I'm going to take the x and distribute it to both. So I have x squared plus 10x, and I'm going to actually add my completing the square because I can kind of already see it, equals 144, and I'm going to add my two pieces in. Okay? So let me go through one more time, and I'll pick a different color so you can kind of see it. But the 1/2 times the 2 is just 1, so those cancel. The x that remains, I distribute to both the 10 and the x to get x squared plus 10x. Okay, just so we're on the same page there. Now let's complete the square. In order to get a 10, I know I do 5 plus 5. Well, 5 times 5 is 25, so 25 gets added to both sides. Because I used 5 and 5, I have an x plus 5 and an x plus 5 equals 169 on the right-hand side. So I have x plus 5 squared equals 169. I'm going to box in my equation because I want you in that habit of boxing it in. When I go to solve, I square root both sides first, and then I get x plus 5 equals plus or minus 13. Now, here's the part where you cannot just say plus or minus a number. You actually have to find them because 5 and 13 are just both numbers. So I'm going to do my two equations. X plus 5 equals 13, and x plus 5 equals negative 13. If I subtract 5 on the first one, I get that x is 8. If I subtract 5 on the second one, I get that x is negative 18. Now, we told you should always have two answers. The problem is, now you have a context. If you look at your two answers, one of them is not appropriate. And the answer is negative 18 is not going to work because you cannot have a negative length to a side of a triangle. And so my answer in this case is 8, which is letter C in our multiple choice. Okay, again, when we give you a context, the negatives tend to be the ones that don't work because you can't have negative side lengths, things like that. But be aware, if they don't give you a context, if they don't give you a picture or a relationship, then you can go ahead and use both of the numbers. Okay? Now I'm going to take us just one step further, and I'm going to relate it back to section 4.2 when we talked about vertex form. There are two types that we looked at. Standard form says y equals ax squared plus bx plus c. And vertex form is y equals a times x minus h squared plus k, where you could see the vertex at hk. And that's super important for me personally as a teacher because I want it to relate back to all of the graphing we did in section 4.2. Now what we're going to do is complete the square like we did before to go from standard form to a vertex form. The process is going to be the same. I'm just going to shake up a little bit how we write our answer at the end. So here we go. What I'm going to do is set this equal to 0. Okay? And then I'm going to have to say, can two numbers multiply to 95 and still add to 18? Now you can play around with this. I'm going to tell you if I'm making you go to vertex form that the answer will be no. So here we go. I'm going to move the 95 over, and then I'm going to write it in the same form we did last time. So x squared plus 18x plus something to complete the square has to equal negative 95 plus that same something, because whatever I do on one side, I have to do on the other side. All right? Second thing, 18. How do you get 18? You get 18 by using 9 plus 9. Well, 9 times 9 is 81, so 81 gets added to both sides. And because I use 9 and 9, my two factors are x plus 9 and x plus 9, which equals negative 14 again. Boy. So I have an x plus 9 squared equals negative 14. Now, we boxed this in every other form because we were solving. I'm not solving anymore. What I want to do is go back to a y equals equation where everything is over on one side and the other side is only a y. So here's the next step, and let me change the color so you can kind of see. What I'm going to do now is I'm going to add 14 to both sides so that I get 0 equals x plus 9 squared plus 14. Now, I don't want the 0. We originally replaced that for y, so I want to go back to a y equals equation. This is where I want to go. Now, you might not have to show me the 0 equals. You might be able to go right to y, but this is the general idea. The reason we want you to go to vertex form is because now I'm going to ask you this. Where is the vertex? Well, it's opposite of the x, which is negative 9, and positive 14. And then I'm going to ask you about the transformation. All right, the transformation says, describe to me what happened. Well, I moved, inside the parentheses, I moved left 9, and outside of the parentheses, I moved of 14. And so from vertex form, you should be able to start telling me key things about the parabola. Where's the vertex? How did it move? And then go from there. And so that's our goal with getting to vertex form. 1, you can solve using it, which is fine. And then 2, you should be able to help tell me about a graph. Okay? Now what I want you to do is this one more. This is an on your own question. And I want you to be able to get me to vertex form, or at least get me to that general equation that we've used on the rest of them. And then once you get to vertex form, can you tell me vertex and transformation? And I think through this you probably should be okay, but I want you to take a look, give it a shot. This question is going to get you the points for the notes today. Okay? So that's it for section 4-7. Thanks for watching.